Okay, so this is going to be the second half of the 3.1 notes, and when you're done with this, you ought to be able to finish the worksheet, and they're going to be due on Monday, 9/28, and Tuesday, 9/29, and we'll go over those, and then we'll have a quiz over 3.1 on those same 2 days. So if we look here, we've got the derivative of the natural log, which we've already had, which is over here on the left. If you have the derivative of natural log of x, it's 1 over x. Well, a lot of times the thing after the natural log will not just be an x. It'll be something extra than just x. So when you have something that's extra than just x, it's going to be 1 over that u and then times the derivative of whatever that u is. A lot of people write it like this. So I'm going to show you how to do this first one both ways, and then you can choose whichever way you like best. You also need to know these properties of natural logs. So a natural log of 1 is always 0. When you have a natural log of something raised to a power, you're allowed to move the power to in front of the ln. When you have a natural log of two things multiplied together, you expand them by putting a plus between the natural log of each one individually. And when they are divided, you do the natural log of both of those with a minus sign between them. You always want to expand if you can before you do a natural log. So if you look, this natural log of 2x is not just an x, so we have to use this rule over here. So when I do the derivative of this, you're going to put that it is 1 over 2x times the derivative of that 2x, which would be 2. So this would be 2 over 2x, which will end up being 1 over x when you reduce the 2's. Now, a lot of people use this one right here, which you put the u on the bottom, which is 2x. And it's the derivative of this 2x on top. And if you do it this way, I think you can see you skip a step on reducing. Coming over to this one, you cannot move that 2 in front because this whole x squared plus 1 is linked together. Now, if it had this whole thing in parentheses squared, you could move the 2 in front, but we can't expand this any. So this is going to be, and I'm going to stick the thing that is after the natural log underneath, and then the derivative of that goes on top, and nothing reduces here. So that is our answer on this one. Coming over here, this is a product rule because I have x times natural log of x. So I have to do product rule on this one. So this is going to be y prime is going to equal the first times the derivative of the second. Now I don't want to put a 1 there, so I messed up. I want that sine x on the bottom. And then I got to ask myself, what's the derivative of sine x, which I hope we all know is cosine x, goes on top. And then I hope we all remember this could be simplified to x, and this can be rewritten as cotangent x, is probably what they do on the AP test multiple choice. This one can be expanded because there's a power of 3, so I can put the 3 in front. So y is going to equal 3 natural log of x, and then I can do my derivative, which is going to be 3. And now this is regular old x, so I can put 1 over x, and I just saw that I made a mistake. This is actually a chain rule. I cannot do this because this is natural log of x times natural log of x times natural log of x. If this 3 were in with the x, I could have moved it in the front. So I cannot do that. So I have to use chain rule here. So we start with the outside thing, which is that 3. We move that 3 to the front, and we lower the power by 1. And then we take the derivative of the inside, which is x on the bottom. The derivative of x is 1. So we would rewrite this whole thing as 3 natural log of x to the second all over x, because you multiply this times 1, the x stays on the bottom. I have seen them write this natural log of x squared, where they actually write it as natural log square of x like that. But I would recommend writing it this way. This last problem on natural logs is we got a bunch of expansion on this. We have, first off, we've got this x, and we have this times this, which looks like product rule, but it's not going to end up being, and then we have this square root. So the first thing you want to do is rewrite this without the square root, just like we do all the time. I hope that's x squared plus 1 squared. And then down here on the bottom, we would have 2x cubed minus 1 to the half power. And now we're going to use all these expansion rules up here. So if you look, we can rewrite this as natural log of x for this first one, and then there's a times here. So that means I can do the plus from this one up here, plus the natural log of x squared plus 1. Now that square is not got the natural log squared, so I am allowed to move this 2 to the front of natural log. So I can move that 2, this 2 to the front by using this rule. And then I have a minus because this is on the denominator, so I'm using this rule here. I've got the natural log of this 2x cubed minus 1. And I have a half here, but again, that half is only with this part, so I can move that half to in front of the natural log. So that expanding thing is kind of a big deal if you can do this. So now we're gonna, and this is still y, by the way. I have just expanded this thing, it's still y. So when I do the derivative of this, again, you put whatever's after the natural log on the bottom and the derivative of it on top. And I got plus a 2. That 2 is coefficient, so it stays in front. And then I got x squared plus 1 goes on the bottom, and the derivative of x squared is 2x. And then I got minus, you leave the coefficient a half in front, and then I stick this 2x cubed minus 1 in the bottom. I guess I probably should put parentheses around these. And then I have to do the derivative of 2x cubed, which is 6x squared. And then we would want to do some simplifying probably, because we can take that 2 times that 2x and end up with 4x over x squared plus 1. And then over here, this 6 and this 2 will reduce that to a 3. So this would be minus 3x squared over 2x cubed minus 1. And this is normally how they write these answers on the AP test. They usually do not get common denominators. They usually leave them expanded because that's what the easiest way is to use the expansion rule. Going on to this next part, again, normally e to the x is e to the x, but whenever you have something up there in the power that is not just an x, you do this, you take the e to the same power and then you multiply it by the derivative of that power. So this is a chain rule with e. So when I do this power, and I got a little problem because I can't see that very well. So I got to get my glasses on real quick. Okay, now I can see the power. So anyway, when I do this derivative, it is going to be e to that same power, which is 2x cubed minus 3x. And then I got to take it times the derivative of this power. So 3 times 2 is 6, lower the power by 1. And then 1 times negative 3 is negative 3. Usually we would stick this part in parentheses in the front, and we would not distribute the e to that power. They usually write the answer, man, that is a terrible 3. They usually write that answer like this. And then we got this one over here. So what I would do to do this is I would, first of all, I got a rational exponent. So I would rewrite this as e and move that x from the bottom up to the top and make that x to the negative 1 power, because I don't want to do a quotient rule when I do the derivative of that power. So I do y prime is going to equal e to the same power and then times the derivative of this power. So negative 1 times 1 is negative 1. X, subtract 1 from the power. And then we're going to want to put this x to the negative 2 in the bottom, and we're going to take this negative 1 times e, which will be a negative e to the x minus 1 all over x squared. And that would be the answer to part B. And then down here on the last part, now this says doing a definition of an exponent to the base a. So I hope you see that this base a to the x can be written like this. And this is the definition of a logarithmic function. This is the one that I'm going to be using right here most of the time. So there's a couple powers here that we want to really use. I'm going to be using, now this is if it's just a to the x. So if it's just a to the regular old x, you do the natural log of the base, which base is a, and then it's a to that, it's this thing to the same power. So over here, this is saying u, this power is not just a regular old x, it's got more stuff in it. So when it's got more stuff, you do it the same way. It's a natural log of the base times a to the same power, but then you take it times the derivative of that power. And then when you have something, now this is exponential form, by the way, hope you know that. This is logarithmic form. So log base A of x, this only works when it's an x. So we're going to be using this one the most of the time. So it's 1 over the natural log of whatever this base A is, and then it's times whatever the number is after that, log AX. Now the difference is this isn't going to be a regular old x. This is going to be something more. So it's still 1 over natural log of the base times the same exact thing in the denominator, and then you have to do the derivative of this u part, which is this part here. So let's try this out. And I gotta look, yep, that's just a regular old 2 to the x. So we're gonna just use this easy one when it's 2 to the x. So that means the derivative is going to be the natural log of 2, because if you can see, 2 is in the place of the a, and then it's going to be this thing times the exact same thing, 2 to the x. So that is just regular old one. That's pretty easy. Now do you see the power is not just x? So this one ain't going to work anymore. It's going to be this one. And by the way, this one works for this one as well, but you're doing the derivative of x, which is 1, which doesn't change anything. That's why you don't need that. Coming over here, we got y prime is going to equal the natural log of the base, which that base is 2. And then it's going to be times the same exact thing, which I think that is 2 to the 3x. And then you got to do the derivative of 3x, which is 3. And then when you simplify this, we would normally stick the 3 in front of the natural log of 2 times 2 to the 3x. Now, something you should know is you could simplify this by moving the 3 up to the power. And I don't know how they're going to write the answer on the AP test. Like, one of the rules is you can move that 3, this 3 up to the power. So they could do this. And they could even do another step where they'd make this 8. So they could rewrite this as natural log of 8. So it's fairly important that you realize the different rules, those properties that we did on logs a little while ago. And we have one more. So this one is a log base 10. So we're going to do this one right here because it's a log base 10 of cosine of x. So a is 10, cosine x is that u. So when we do this problem, y prime is going to equal, and we're going to get 1 over, and then we got to do the natural log of the base, which is 10. That's that part there in parentheses. And then whatever the u is, that's that thing out here. This cosine has to go after that. And this is all in the denominator. And then it's going to be times the derivative of cosine, which is negative sine x. Now you can just put that right on top, kind of like we did those problems earlier. So I hope you see that this is going to be a sine over cosine. So we can simplify this to negative tangent, because that negative sine over cosine is tangent times 1. That's negative tangent x all over the natural log of 10. And that might be how they write this as a simplified answer. So that's all of the Unit 1 notes. Oh, I think I got one more, don't I? Yeah, we got an actual problem. This looks like it might be an old AP problem. I'm not sure. But this is like one they're going to put on your quiz probably coming up. The values of two differentiable functions, f and x, along with their derivatives, are given by the following values. Now, when you see something as differentiable, if anything tells you differentiable, I want you to start writing something down. I want you to write that f of x and g of x, and we're going to say because f and g are differentiable, f and g are continuous. Because if they are differentiable, they have to be continuous. So you need to start writing this down because we're going to use that later when we use some theorems to prove things. So if you look at this right here, this is a composite function, which means we're going to use chain rule on this one because we got to get h prime up to. So we're going to do h prime first. So the rule of when you're doing chain rule is you start and do the derivative of the outside, keep the inside identical, then do the derivative of the next part, which is this part in here. So that's g prime of x. And then last you do the derivative of the x part, which is 1, which will change nothing. And then we have to go through and we got to do h prime of 2 because that's what that 2 is what we're looking for. So we need to plug 2's in for all of those x's. And I'm not going to put the 1 down there because 1 times anything doesn't matter, so we don't need this part. All right, so I'm going to go up here to my chart. Here's my g, because I'm looking for g of 2 right here. So there's my g. There's when x is 2. It gives me a value of 3. So this is going to be f prime of 3. And then I need g prime of 2. So g prime is here, 2 is there. So this is 3/2. And last but not least, I need to find f prime of 3. So there's f prime, there's 3, that's -1. So this is -1 times 3/2, which will be a -3/2. So that would be the answer for h prime of 2. Coming over here to this is also a composite. So we have to do the outside first. So, and again, that says f prime, so we got to do the derivative of this. So f prime of x, and it says do the derivative of the outside part first, keep the inside identical, then times the derivative of the inside part. So that's f prime of x. And again, there's a 1 out here because you do the derivative of x, but that's not changing anything. So now I need to plug in 1s for my x's. And then I'm going to go up and get my numbers out of my chart. So I need f of 1. So here's f of 1 is 5. So that means I need g prime of 5 because I'm getting 5 is f of 1. And I need f prime of 1. So f prime of 1 is -1. So this is -1. Now I need g prime of 5. There's g prime. There's 5. So that's -1/2. So I got -1/2 times -1. So this would be 1/2. And again, after you plug these in, you could have stopped. I could have stopped here, and I could have stopped here. But this will be a multiple choice question, and they will have -3/2 and 1/2. So I hope you guys get ready for this quiz coming up on the 28th and 29th, and I'll talk to you later.